this section, we are going to be talking about the moon. And moon exploration has always been something I think a lot of people have wanted. In 1957, the Soviet Union launched the first artificial satellite, which was Sputnik 1. A few years later, they had the first human in space. That same year, we had the first American in space, Alan B. Shepard, on Project Mercury. And a few years later, the United States had Project Gemini, which had two-person crews in space. And then in 1969, Neil Armstrong, Buzz Aldrin were part of the Apollo mission, which started the exploration of going into space, exploring it with different vehicles like the lunar rover that you see there. And eventually, scientists would really like, astronomers, NASA, a lot of people would really like to have a space station up on the moon where people can stay and live and use that as a landing space for study. So, the moon is interesting because it always looks the same. Like if you look at it now or 40 years from now, it'll basically look the same. Interestingly, the same side faces us all the time, and we'll talk about that. But also, there's not a whole lot of uh, wind or water or even current, like heavy impacts that are altering the surface of the moon. So it relatively stays the same all the time. So the albedo of the moon, which is the light reflecting back from the moon, is about 12%. So about 12% of the light that gets sent to the moon gets reflected back that we see on Earth. Interestingly, the Earth actually reflects more light for a lot of reasons. One of those is water, but we reflect back about 30%, so we're actually brighter from space than the moon. So the moon's surface, because it does not have an atmosphere to absorb heat, the sun, when it hits the moon's surface, because it doesn't have the atmosphere to protect it, it will get as high as like 127 degrees Celsius. This is well over boiling. And then it gets well under freezing on the side of the moon that does not have the sun at all. Now, people for many millennia have seen some kind of figure in the moon, a man in the moon. I had to look this up because my imagination has never been good enough to see the man in the moon. And there were all these weird different pictures on Wikipedia that, I don't know. I guess I maybe always saw this weird rabbitish thing or I don't know. I am not creative enough to see anything in the moon. But there's different features on the moon. One is the Highlands, and they are heavily cratered areas on the moon where it's been impacted by different things that hit it during its formation. The Highlands are the oldest forms on the moon. The next that we're going to talk about is Maria. They are somewhere in the middle age-wise. They're dark and smooth plains. And then the last one is the rills. They are valley-like structures, probably sunken lava tubes that are extinct now. And rills are the youngest features on the moon. So the craters on the moon that are here were formed because of major impacts that hit them. Different things that hit as the moon was forming formed these craters, and some stuff did end up blasting back out into space and recollecting on the moon or just being lost in space, and this was called ejecta. Ejecta are just things that blasted back or sent things in different directions. And from ejecta, you sometimes get these features. I don't know if you can see it in this picture. Check it out in your book. But you have basically rays, just like the rays that come off a sun. How, you know, kids or even me, because I'm not a great artist, draws the sun. You draw rays coming off of a circle. Those rays are where ejecta, went past and left a pattern there. So, what makes our moon special or different or unique from any other moon? Well, there are some things. First of all, we have a big moon compared to the size of our Earth, and there's some moons that are bigger compared to their planet, but we have a bigger one. Our moon also has a solid rocky body, and a lot of moons are actually ice. So the fact that ours is solid rocky makes it different than most. And then also, our moon is kind of far away from the Earth compared to most moons would be closer to their main planet. So the moon was heavily bombarded during its first 800 million years. And because of this, a lot of large rocks got broken up, heavily broken up. And this broken up rock can go a few meters deep in some areas on the moon. Like, if that would be very unique to have several meters thick of loose rock that is just broken from impacts. If that was here on the Earth, it would probably be human caused. And so it's interesting that it does have those areas. And these are called regoliths. So regoliths are deep areas of just broken up rocks from impacts that the moon had. And astronomers tend to think, for a couple reasons, that the moon has these layers: a crust, an upper mantle, a lower mantle that is maybe partially molten, and then a core that is iron, which is similar to the Earth. And scientists think that when lava originally welled up from the moon's interior, that it basically came out and made the smooth plains that are the Maria that we saw earlier. So scientists also think that the moon doesn't have plate tectonics, and they think that because the mountain ranges on the moon were formed by impacts, not tectonics. There's also no current volcanoes, and there's not much of a magnetic field. So all of those things make scientists think that their plate tectonics is not happening on the moon. And then the formation of the moon, there's a good picture of it here. There's better pictures online if you ever see them. But basically a large body that was Mars-sized came and collided and hit the Earth. This created a large impact. Things got busted up and started floating around with the gravity. Over time, that ejecta that got sent out started collecting and collecting and collecting into a ball until we have our current moon that has collected most of what is in its orbit.